In science today, we are going to revise energy, heat, atoms, and nuclear energy, as well as waves. What is energy? Energy is what makes things happen. It is the bang behind a firework and the roar of a racing car. It pushes planets around the sun and helps trees reach for the sky. It makes earthquakes that can tear the ground beneath our feet and music that makes us get up and dance. Energy is the hidden power behind everything, including life on Earth and all that happened there. Or happens there, rather. Everything you do needs energy. All the things you use are made using energy. And everywhere you go, you need energy to get there. It is no wonder that the world uses so much energy. Around 80 to 90% of it comes from fossil fuels such as oil, coal, and gas. We burn them to release that energy locked inside, which we can then use for heating, cooking, or generating energy. Most of the world's energy is used in three ways: in our homes for transport, and in businesses and industry. Everything in the world is either energy or matter, and even matter is a kind of energy. Trees capture the sun's energy in matter by using it to power the growth of their branches and leaves. If you burn wood, you release trapped energy as heat and light. Energy makes things possible. Science definition for energy is the ability to work, and it is measured in joules. There are multiple kinds of energy you can see here: light, heat, chemical, kinetic, and electrical. More about that later. Types of energy. The world is bustling with energy. Your TV flickers with a light, your voice makes sounds ripple through the air, and your muscles have energy packed inside them from the food you eat. A spider climbing your wall stores energy by walking against the force of gravity. Even this book has energy hiding in its atoms. Everything you see is either storing energy or using it. Stored energy is called potential energy. It is like money in the bank. It is energy that we have saved up that we can use later. We can store potential energy in different ways by working against forces. If you push a car uphill, your body works against the force of gravity, which is trying to pull the car back down. You lose energy from your muscles, but the car gains potential energy. If you let the car go, it has the potential ability to roll down again. Used energy is saved energy. No, used energy is not saved energy. We can use stored energy to do all kinds of useful things. If you let go of a ball at the top of a hill, it rolls down. The potential energy it had at the top is quickly converted into movement, kinetic energy, as it speeds along. In just the same way, the chemical, nuclear, or elastic energy stored inside things can be changed into other kinds of useful energy. Potential and kinetic energy. Our hectic world is powered by energy. Nothing can happen without it. But where do the things that rush around us get their energy from? Things that are moving have kinetic energy, which means they have to get it from somewhere. Often they make it from their own stored up energy, which is called potential energy. What happens to your energy? We cannot make energy appear or disappear like magic, but we can change its form. When this athlete lifts her weight, her muscles use up stored potential energy. Her body loses energy as she lifts the weight and gains potential energy instead. When she drops the weight to the ground, the potential energy turns to kinetic energy. And as the weights hit the floor, its kinetic energy turns into other types of energy: noise, elastic energy as it bounces up and down. Energy spectrum. Light is energy we can see, but it is only one small part of a whole spectrum of energy rays that stream across the universe. There are many types of energy similar to light that are invisible to us. Like light, these are made from waves of electricity and magnetism racing around at high speed. We call these different energy waves the electromagnetic spectrum. Microwaves use radiation and is absorbed by water where it turns into heat energy. Microwave ovens use this energy to heat up food. TV and radio programs race to the sky using radio waves. We can see distant light rays using a telescope, but to detect radio waves, we need a metal aerial or a dish-shaped radio telescope, just like the dish you have at home for DSTV. I don't know. We don't use them anymore. We all have Netflix, so. Then we have infrared rays. The heat you can feel beaming from things is a kind of invisible hot light called infrared radiation. Like light, it travels instantly and in a straight line. Then we have ultraviolet light. The sun pumps out light we cannot see, including harmful ultraviolet that can cause sunburn and skin cancer. Sunscreens help stop this harmful radiation from reaching your skin. Then we have X-rays. Light cannot get through skin or bone. More energetic X-rays get through skin but not bone. They can make shadow pictures of our skeletons that show up broken bones or some illnesses. Then, last but not least, the gamma rays. Some atoms give off powerful and dangerous radiation called gamma rays. They are the most energetic form of electromagnetic radiation, and they can travel right across the universe. Heat. Atoms constantly jiggling about with energy. We call this heat energy. The more heat something has, the faster the atom jiggles. Even the coldest object has some heat energy, as the atoms are always jiggling around. If we could stop the atoms from jiggling, we could make an object completely cold. We call this temperature absolute zero, although no one has ever managed to cool anything down that much. The sun is probably the hottest thing you can imagine. If you could peek inside, you would see it exploding with heat. If you look at the atoms in the right top corner, you can see the cold ones are vibrating softly and the hot ones are vibrating faster. Measuring heat. The temperature of an object tells us how hot or cold it is. We can use this to tell whether food is properly cooked, if a person is suffering from a fever, or if a car engine is overheating. These days we have electronic thermometers that can measure temperatures for us quickly and accurately. But in the past, humans relied on changing in nature to measure temperature. Crickets chirp by rubbing their wings. On hotter days, they chirp faster. You can tell the temperature quite accurately by counting their chirps. Heat changes things. Heat is a type of potential energy. It is stored energy that has the power to change things in surprising ways. If you heat ice, it will turn into water and then steam. The energy you add causes a spectacular change, turning a solid into a gas that looks nothing like the ice you started out with. Heat changes different substances in different ways. It can cook things, burn them, or melt them. Evaporation. Heating liquid makes parts of them turn to gas and disappear, cooling the liquid left behind. This is evaporation. Sweating works by evaporation. Our bodies cool when sweat evaporates from our skin. Freezing. Most things shrink and go harder when you remove heat. Frozen food goes hard, while flowers cooled to low temperatures shatter like glass. Burning. Heat things with oxygen and you can start a dramatic chemical reaction called combustion. Flames are made when the vapor given off by a burning object catches fire. And melting. Things that do not burn can melt instead. Melting means turning from solid into liquid. Water melts at 0 degrees Celsius, but bronze melts at 900 degrees Celsius. Coffee always goes cold, and ice cream always melts. Hot things cool down, and cool things warm up, because heat is constantly on the move. Although heat transfer is sometimes a nuisance, it can help us do many things. A refrigerator removes heat from food to keep cool and fresh food, while an oven heats the same food up to cook it. Heat transfer dries our clothes indoors or out and keeps our homes cozy in the depths of winter. But why does heat move? Heat moves when things are different temperatures. It always moves from hotter to colder things, never the other way around. In winter, you are hotter than the air around you. Heat flows out from your body and it's hard to stay warm. On summer days, heat flows into your body and it's hard to keep cool. There are 3 ways to heat something. One is through convection. Convection is when hot liquid rises above cooler ones. Heating this way it's like a hot air balloon, guys. Heat goes up, cold air goes down. So if you put something over something that is warm, the hot air will travel up and the heat will eventually get to the frying pan. And then conduction. When you put a saucepan on the stove directly onto the heat transfers from the stove through the pan to the water by conduction. See, so the flame is directly touching the pan. That is conduction. When the air has to travel up, then it's convection, and then conduction is when the flame actually touches the pan. For example, if you are having a braai, you put your meat on the braai and it cooks through convection or conduction. It cooks through convection, I hope, otherwise you're having charred meat. Anyway, and the last one is radiation. Radiation is like a hot lamp that beams heat through the air and in all directions, just like the sun, okay? Now when this pan is very hot, you can put your hand over it and you can feel the rays of heat that is radiating off the pan. And then, did you know you can dry your clothes using all 3 ways of heat moving. When we can dry clothes outside using conduction, convection and radiation. If we lay it on a warm ground, it dries by conduction. If we hang it in the air, convection plays a part. But when the sun shines on the washing, radiation warms the cloth and the water inside, helping the water to evaporate. So when we hang our laundry outside on the washing line, we use both convection and radiation at the same time. The best way to keep warm is to stop heat escaping. This is called heat insulation. We wear layers of cloths in winter because they trap air between them. This reduces heat conduction, convection and radiation from our bodies so we stay warmer. Animals do the same with thick layers of blubber and fur. The feathers on a penguin's coat trap air just like the layers of clothes we wear. A hot drink stays hotter much longer if you put it in a vacuum flask. Inside, there's a glass or metal bottle surrounded by a vacuum, which is an empty space with no air inside, and plastic to stop heat getting out so quickly. Vacuum flasks also stop heat getting in, so you can use them to keep cold drinks cool as well. You can fit 1,000,000 atoms on the head of one single pin. Each one of these tiny bits of matter has the power to make a massive amount of energy. We can release this energy by smashing an atom apart or crashing two atoms together. Some atoms split all by themselves, giving off a kind of energy called radioactivity, which can be dangerous but very useful. But why do atoms contain energy? Suppose you had all the bits to build an atom, a big pile of protons, neutrons, and electrons. You should squeeze them together, but you would need to use massive force and energy to do so. If they stayed together, the energy you use would be locked inside the atom as potential energy. This is the energy that gets released when an atom smashes apart. What is radioactivity? Some atoms are unstable and break up to make more stable ones. When they split, they give off radioactivity. This can be chunks of atoms called alpha particles, flying neutrons called beta particles, or waves of energy known as gamma rays. Radioactivity is very dangerous, but it can be very helpful. In hospitals, radiation treatment is sometimes used to treat cancer. A beam of radiation is fired at tumors, harmful growths in the body, to kill them and to stop them from spreading. Food is sometimes treated by a similar way so it lasts longer in the shops. Take a look at the fruit. Fruit stored at 20 degrees Celsius 14 days after no irradiation gets moldy, while fruit stored at 20 degrees Celsius for 14 days doesn't. It stays healthy because the gamma rays kill the bacteria. Some people argue against this because radiation can also kill minerals and vitamins. German-born scientist Albert Einstein discovered that a tiny amount of matter can change into a huge amount of energy. This is the basic idea that makes a nuclear power station work. It also explains why a nuclear bomb causes a massive explosion and a huge amount of damage. You also get nuclear power stations. They are called nuclear reactors. Nuclear reactions release a lot of energy. We can use a nuclear reactor to turn this energy into useful electricity. Instead of burning fuel like an ordinary power station, a nuclear reaction uses energy from splitting atoms. But this creates a lot of nuclear waste, so it's not necessarily a good thing. Almost all our energy comes from the sun. When sunlight hits the earth, it makes plants grow, which feed animals, including humans. Packed full of food, animals have the energy to do all kinds of things. Even the simplest things an animal does, such as thinking or sleeping, can use up a lot of energy. But energy lasts forever. It cannot be created or destroyed, but it can turn from one into another. Every single burst of energy that beams down to Earth from the sun has to go somewhere. All energy can change into another form. It keeps changing until eventually becomes waste heat that we can no longer use. When something loses energy, that energy has to go somewhere. When you feel hungry, it means you have used up the energy you took in from your food. Some of it has to keep you warm. More has been used by your brain for thinking. You have even used some moving about. If you add up all the energy your body uses in different ways, it comes to the same amount as the energy in the food you eat to start with. A British scientist, James Joule, showed how energy can change from one form to another. In 1845, he proved that when something loses energy, another thing must gain the same amount of energy. This is called the conservation of energy, and it's one of the most important scientific laws. In this picture, you can see how chemical energy turns into mechanical energy, and electrical energy into light, and light into chemical, and chemical into light, and chemical into mechanical, and electrical into heat. So awesome how God created the earth. Waves. When winds roar across the ocean, the water whips into towering waves that ripple around the world until they crash onto the shore. Waves are how energy travels from place to place. Waves on the ocean are formed when energy from the wind is transferred into the water. Earthquakes also create giant waves, which can shake the surface of the land, creating towering tsunamis out at the sea. Surfers can zoom across the ocean because waves are packed full of energy. The higher and faster the wave, the more energy it carries. Then you get dangerous waves. Earthquakes often strike under the ocean. A large quake jolts the water above it very violently. This sudden release of energy causes waves to race across the ocean surface. The waves carry massive amounts of energy, and when they reach the shore, they can be higher than buildings. They continue onto land as a tsunami, a massive wave that can flatten everything in its path. And then we have the epic earthquakes. Earthquakes are waves that shake the ground beneath our feet. Earth's land masses are built on a giant rocky plate that grinds slowly past another one. Sometimes they jolt up and down, causing a massive release of energy as cracks called faults. This energy races through Earth as a high-speed wave, producing an earthquake on the surface.
That's all, folks.